Kevin, it seems what you're describing here is that there is a large part of the scientific community that is in kind of a desperate attempt here to preserve age. But here it seems that we have evidence that, at least to me, and of course I'm not a microbiologist, but I think most people would say, well, that just seems reasonable to think that maybe these are not that old. But it seems like there's a desperate attempt to hang on to a lot of time. Why is that?
Time is the critical component for evolution. If you're going to say that a simple cellular system became a multicellular system that then became fish, and the fish then jumped up on land and grew legs and started breathing air, and then that creature grew feathers and wings and started flying. So if you give us time, we'll claim to account for all of this massive change of organisms, but we got to have the time.
So what you're saying is that if you pull out the notion of a long period of time, you're pulling out a major foundation for the conventional paradigm.
Absolutely. Evolution, specifically neo-Darwinism, requires a lot of time. And it's their foundational issue. You pull that out, they've got to come up with a whole new understanding, because without time, they don't have anything.
Well, as a microbiologist, looking and understanding, no doubt, that conventional paradigm that requires a lot of time, why does it require a lot of time? Does that bring us to the issue of mutations?
The mechanism claimed to drive evolution is mutation, where we'll define mutation as a change in the nucleotide sequence of DNA. So the driving mechanism claimed for evolution is a mutation, and then natural selection looks and sees what effect that mutation had. And if it likes it, and this is giving, of course, a lot of power to natural selection it doesn't have, but if natural selection likes it, see, then that organism survives. If it doesn't like it, then that organism dies off. And then you do the next step, and you keep repeating that step over and over again. The idea being that somehow in that process, the fish who only breathes oxygen through water, who doesn't have legs, whose vision is based upon seeing through water, not seeing through air, somehow plops up on land, and through these very slow processes transforms its entire anatomy and physiology where it can breathe air, it can walk on land, and it can see in air. And so they see it as, you give me enough time, we can account for all of this. See, now it really doesn't, but time becomes one of those things to a human, you know, yeah, it's almost like anything can happen given enough time.
Mine gets fuzzy when you
Yes, and they hide behind that fuzziness. It just took a long time. Somehow that becomes the magic wand, you know, a long time, poof, there it is. Forget the idea that there's no biological mechanism that accomplishes that. Time, poof, we got it.
But we have heard, I think over and over again, that the notion of mutation really does happen quickly, because you know, we're talking about bacteria and those kind of things that we're told, well, they mutate very quickly and they can change rapidly. This is your specialty.
This is my specialty. The first point I need to make is that Darwin wrote his original ideas in a time where there was very little known about the cell and even less known about genetics. Now, Gregor Mendel, who's kind of considered the father of genetics, he did the pea plant studies and all that, he and Darwin were peers. And there was even found in Darwin's library an unopened copy of Mendel's paper. But it's questionable even if Darwin would have opened it, if he would have understood it, because, and that's not putting Darwin down, that's just a matter of most people in that time didn't understand Mendel's studies. They just simply didn't understand it. And so Darwin proposed these ideas, and they became very popular at a time where genetics and even cellular biochemistry was not well understood. So in essence, there was this big vacuum of lack of knowledge that they were able to quickly step into, and we could just pretend that it all made sense, because maybe, maybe not, we just simply didn't know. You could not, and this is a challenge I put out over and over again, you could not today present Darwinism and it be accepted, because we would know better. But because it's already accepted, then, well, it must work somehow. But if you came in today with what we know about the biochemistry and the genetics of cells and tried to propose brand new, as a fresh idea, neo-Darwinism, it'd be laughed at. But it's not laughed at because it's the accepted paradigm.
And so we struggle to look at things like this and maintain the paradigm, rather than maybe from an honest perspective to sit back and say, well, this may be telling us something that is going to change the paradigm completely.
Examples of, again, the paradigm driving the conclusions. Several years ago, I listened to a Nobel laureate give a talk, and in that talk, he described cellular systems as Rube Goldbergs. You know what that is, where it'd be all hobbled together. And he was a Nobel laureate trying to claim that because of evolution, evolution just hobbles things together, whatever works. So the cellular systems are all hobbled together. So he called them Rube Goldbergs. And even at that time, I thought that's a very, very foolish thing, especially in absence of not knowing. But what we already knew, I felt challenged what he said. I would defy him to say that today in the face of what we know about cellular systems today. They're not Rube Goldbergs. They are enormously sophisticated, where we still don't understand. It's still beyond that. And the DNA is a classic example. The Human Genome Project, the irony is that instead of the Human Genome Project destroying the foundations of biblical creation and all that, it has been one of the biggest booms, one of the greatest things for creation to ever happen. Because among other things, what it has shown is it has shown that in each cell in your body that has chromosomes, there is a system going on there that we don't yet have more than the very minor understanding of. Let me give you an illustration. Let's say you take the book War and Peace, 2,000 pages. Let's say you are able to write it in such a way that it's on 20 pages. Now, this isn't 20 pages of small print. This is just 20 normal written pages. Okay, but the way you read that book is you read it left to right, top to bottom, but then turn it over and read it left, right, top to bottom. And then you take a page and you fold it into another page. And then you take another page and fold it into another page. And you keep, see, it becomes three-dimensional. But it's actually four-dimensional because time's involved, because each time you fold the page, there's been a change of the information in the book. And the book reads the entire novel. It's not like you start with each fold, you get a different story. It's the continuation of the novel. That's an analogy of the human genome. And so the question is, would we know how to read that book? I would know how to read that book. Would we even have a clue how to write that book? Of course not. And yet that book's been written. It's called the Human Genome. Now, you cannot tell me in rational terms that a process that relies on mutation and natural selection could write that book. Don't even begin to pretend that I'm going to buy into that. It doesn't make any rational sense whatsoever. Evolution can't account for this. The human genome has gone so far beyond evolution now that they're just stumbling in the dark. And oh, I'll get people to write me, what about this and what about that? Well, you don't know what you're talking about. You don't understand mutations. I spent 20 years studying mutations. Say, I was talking to a gentleman just the other day and I said, well, beneficial mutations, you know, we define a beneficial mutation as a mutation that provides a benefit to the organism. In other words, I'm now resistant to the antibiotic, which is beneficial if that antibiotic's around, you know, okay? As a human, I like to drink milk, okay? I have a mutation in me that allows me to drink milk. It's a mutation.
Oh, is that right?
To me, it's beneficial, you know, but it's still a mutation. So if you look just at beneficial mutations, which is what evolutionists love to look at, beneficial, 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 and I say, but that's really irrelevant. What's happening at the genetic level? That's the key. It's not whether it's beneficial or not beneficial, it's what's happening genetically. And what we see, for example, with antibiotic resistance. Antibiotic resistance comes by one of two ways for the most part. You have a vector come into the organism, which is bringing in some kind of gene that makes it resistant. Okay, well, that vector already exists. You're not introducing anything new into biology, it's already there. So that doesn't account for the origin of anything, it just counts for how it moves around, okay? The key thing then becomes mutations. That's why evolution is mutation and natural selection. Because if you do change the sequence, that has the potential to give you a whole new genetic component, a whole new genetic activity. But when we look at mutations that cause antibiotic resistance in bacteria, what they are is mutations that eliminate transport proteins, eliminate enzyme activities, eliminate functionality of certain proteins, eliminate, reduce, cut down, eliminate. See, is there a trend here?
Yeah,
okay. With lactose utilization in a human. The reason I can drink milk is because the normal regulatory system that shuts down the gene that makes the enzyme so you can digest lactose, when you move through puberty, that gene gets shut down. If you have the mutation, that blocks the shutting down. But what have you done? What you've done is you've eliminated a pre-existing system. There are people that are actually resistant to HIV. Do you know how they're resistant to HIV? They are missing the key protein the HIV virus binds to. And if the virus can't bind, it can't infect. Now, if you're exposed to HIV, that'd be pretty beneficial mutation, right?
Sure.
But what's it caused by? It's caused by loss of a pre-existing protein. And so what we see, and I can go on and on, what we see is repeatedly what the evolutionist community does is they offer example after example after example of what they claim, here's how evolution works. No, it's not. Because what you're doing is you're taking pre-existing systems and knocking them out or reducing them. You're not explaining how they evolved to begin with. It's the analogy of if you have a house, and in your house you have the dining room and a wall and then your recreation room. And your wife, being, you know, the big socialite that she is, she wants a bigger dining room to entertain her parties. Well, you have a choice. I can keep my rec room or I can knock at that wall and get a bigger dining room. Well, you know, everybody knows happy wife is a happy home. So you knock out the inner wall and they have a bigger dining room. And it's beneficial because she's happy. But don't tell a carpenter that how you built the house was by knocking out a wall. But that's what evolutionists do repeatedly is they give you an illustration of knocking out a wall and this is how the house was built.
Now, Kevin, a lot of your research was done in the area of studying bacteria.
Correct.
Is that correct?
Correct, yes. Particularly mutations in bacteria.
Yeah, okay. And I want us to examine that for just a second because I know, and I have heard, and many people have heard, how often the notion of how bacteria mutates and therefore survive as being a key piece of evidence to say that, well, the evolution of mankind and animals must be true because we see it in bacteria. Is that a proper way to compare them?
It's even called evolution in the petri dish.
Okay.
Yeah, they like using bacteria because first off, you have very short generation times because you can get several generations in a day. You know, even if you're studying fruit flies, it takes more than a day for a generation. Okay, so bacteria make themselves very nice as a system when you're trying to study a lot of generations. And bacteria readily mutate, so that makes it very nice also. See, hopefully humans don't readily mutate to the extent that we constantly change our physical features, so that makes it a little tough to study humans when you're wanting to study the effects of mutations. But bacteria readily mutate, and so a lot of that makes it a very good model for studying those kind of problems, for studying what do mutations do, what causes mutations, you know, what happens to the mutants after they form. Now, the problem becomes that humans are not bacteria. Bacteria can make a fairly dramatic mutation and then come back later and correct it. Let me give an example. To become resistant to certain types of antibiotics, some bacteria will eliminate an enzyme or a transport protein. Just get rid of it. Now, if a human got rid of a certain enzyme or transport protein, we'd probably die. If we didn't die, we certainly wouldn't be very healthy. The bacteria may experience some loss of health, shall we say, but it survives the antibiotic. And then once the antibiotic is gone, it starts making that again. It regenerates. Humans can't do that so easy. We can't just shut things on and off like that. And particularly because our generation time is, every 20 years, not every 20 minutes. Bacteria, because of the generation time, they can reproduce very quickly, and they can pay what is called cost of selection. If I were to expose a large container of bacteria to a very, very traumatic environmental condition, like starve them for an amino acid, I may kill 99.9999% of that population of bacteria. But the next day, those few that are left that have the mutation that allows them to compensate for, lack of a particular amino acid in the media, they've regrown and the whole population is restored again. Just boom, just like that. Whereas with humans, if you wipe out 99.99999% of the humans, first off, that's a potential extinction event. But second off, even if we do survive, how many centuries and millennia will it take for us to recover from that? See, so bacteria can pay that extremely high cost of selection, where you eliminate almost all of them, but a few survive, and the population returns back very quickly, and voila, evolution has occurred. That's what we're told. And it can't really do that in humans and in dogs and in cows and such. They don't respond that way. So what works for bacteria doesn't really work very well for animals. But because bacteria is so easy to study, they like to extrapolate. Like say, well, look, this is how it would work in the animal too. Well, not necessarily. So the comparison of us and bacteria only goes so far, and then it starts falling down.
Kevin, how would you define science, first of all?
I just simply define science as a tool that we use to understand the world around us. And it's just simply a tool. Now, within science, there's obviously a certain methodology. But science itself is just a general approach that's used to try to understand, what's happening. Understand, what do we see here? Understand, what is it that causes thunder? What is it that causes earthquakes? What is it that causes you to be sick? It's never been a matter of science this way, creation that way, science this way, the Bible that way. So many times that's put as the paradigm, and that's never been true. It's always been the opinion of some people versus the Bible, the opinion of some people versus creation, because science doesn't hold an opinion. Science is a tool. Science is a tool that is used to understand God's creation, is what it really comes down to. It's a tool to understand what's around us. See, so science then hopefully gives us better understanding of things. But that's really all it is. The idea that science has to only offer a natural explanation and cannot in any way account for God, that's absurd. That is a definition intended for their very purpose of eliminating God. And I would challenge people that would consider themselves Christians and evolutionists, sometimes known as theistic evolutionists. I would challenge them to consider that evolution as an official scientific idea, as in what's in the literature, what's in the textbooks, what's talked about at scientific meetings. Is God ever in any of that? Of course not. Evolution is viewed as kicking God out. So as a Christian, why would I ever be attracted to something that prides itself on kicking God out? And theistic evolution is considered no more scientific in the scientific circles than creation is, because it involves God. Evolution claims it doesn't need God. Okay? God certainly doesn't need evolution. So why would you try to mix the two? I don't know why you would.